Hello there! Welcome to Chapter 7, 7th graders. Here we go. We've got zero and negative exponents happening here in Chapter 7, Section 1. Let me tell you about Chapter 7. It's going to feel easier to you, and in a sense it is. But I'll tell you what, it's also really easy to do this, to make mistakes if you're not really careful, and there's some rules you're going to have to learn very carefully. So pay attention to your detail here to survive it. It'll pay off. This is the first page of the notes that you should have picked up. And you know what? I'm not even going to talk through this. You do need to work through these this page. So please do that, even if you need to hit pause now. Work through this page. I'm going to hit number 4 here real quick. Using an exponent here, 35 times 35 times 35. What that equals 35 to the power of 3. So when we have exponents, it's multiplication that many times. 19 here, we count up the 19s, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 19 to the power of 9. So the exponents create a way for us to write very large numbers in a real simple way. In number 6, this is important here. And this 4 to the power of 3, okay, the base is the 4. Okay, so that 4, that is the base, and the exponent is the 3. Okay, you'll need to know that because I'll use that language a lot. The base is the number that is getting multiplied. The exponent is the number of times it gets multiplied. Okay, this kind of talks about negative numbers and some examples of that. We need to move on because we've got a lot of detail to talk about in the next page. So I want to jump over to this page right here because this is wild and crazy as we introduce zero and negative exponents. Okay, over here I want you to copy this down. 2 to the 4th is equal to, now quick review here, 2 to the 4th, that means 2 times 2 4 times. Alright, so that is equal to 16. So 2 to the 4th is equal to 16. Okay, now I'm going to go down to 2 to the power of 3. And that would be 2 times 2 times 2. Well, that's 8. 2 squared is equal to 2 times 2, which is 4. 2 to the 1, that's just 2 times just 2. So that's that. And then if we follow the pattern, okay, observation time here, let's take a look at the patterns. Look for patterns as I move down the page in this chart. Now this is really important because this will help you understand something that if I just have you memorize it, it might not make sense. I'm going to show you why this works. Notice I'm keeping the base 2 the same, and notice what happens as I move down the chart. 4, 3, 2, 1. So my next one, if I continued in that pattern, the next one would be 2 to the 0. Alright, and then going down that chart, so I go down 1, down 1. Let's look over here as I go downhill, and let's see, ask ourselves what is happening each time as I go down the list here. 16 to 8, 8 to 4, and it's got to be the same. I'm dividing that by 2. 16 divided by 2 is 8. 8 divided by 4. And that actually makes sense if we think about it, because when we use an exponent, we're multiplying. So as I go up, I'm multiplying another 2. So I'm kind of just doing it backwards here. So the question is, if I continued that pattern to the next one, and I took 2 divided by 2, hopefully you've already written on your paper, 2 to the power of 0 is 1, and that's correct. In fact, that leads us to this first rule right here. For every non-zero number a, that means that a is not 0, non-zero number. Any number to the power of 0 equals 1. Look right here, 6 to the power of 0 is 1. Negative 24 to the power of 0 is 1. All right, because the negative is in the parentheses, that means the negative is going to the power as well. That is 1. So any number to power 0 equals 1. Okay, that's important. You need to know that. All right, well, before we look at this bottom part here, let's watch this. If I continued going down, what is it that would be my next exponent? Now notice I'm just going 4, 3, 2, 1, 0. So that would be -1. All right, well, let's continue our pattern because the pattern has to stay the same. Even though that exponent has become negative, I divide 1 divided by 2. What is 1 divided by 2? And don't give me a decimal. 1 divided by 2 is 1 over 2. 1 divided by 2. Well, that's interesting. Let's keep the pattern going. 2 to the -2. All right. Whoops, that's a bad equal sign there, but that's an equal sign. If I take 1/2 and divide it by 2, it's like multiplying it times 1/2, right? 1/2 divided by 2 equals 1/2. Remember how to do this? Times the reciprocal of that, 1/2, which is 1 over 4. So that's 1/4 to the -3. If I continued that, I can't write equal signs. 1/4 divided by 2, well, that would be 1/4 divided by 1/2, that would be 1/8. And if I kept going and got to 2 to the -4, that would be 1 over 16. Now take a look. There are all kinds of things happening here for you to learn. First of all, did the answer ever become negative? Never did. It doesn't. The negative exponent does not turn the number negative. That's the first thing you have to remember. It just makes the number smaller as I go down. Another observation to make here. Notice this -4. What it did is, notice that 16 here. Notice this 4 up here and this 16. You see what happened here? 2 to the 4 is 16, but 2 to the -4 is 1 over 16. Well, that's interesting. Let's look at the 3. 2 to the 3 is 8. 2 to the -3 is 1 over 8. Did you notice that? Does it happen on all of them? Yes, it does. 2 to the 2 is 4. 2 to the -2 is 1 over 4. 2 to the -1 is 1 over 2. 2 to the 1 is 2. The negative exponent will not turn the number into a negative. It takes the reciprocal of the base. It takes the reciprocal of the base. So, with that, leads us to this right here. Okay, this chart is like exponent is 0, it's 1. If the exponent is negative, and here they're trying to explain what I just told you. For every non-zero number, means a is not 0. Okay. The number a, an integer n, so it's some integer. If that n integer is negative, a to the -n is equal to 1 over a to the positive n. Look at an example. 7 to the power of -3 is equal to 1 over 7 to the third, or 143. 7 to the third is 143. I'll show you in class how to use your calculator to do that real easily, if you have your own calculator, which you're really going to want your own calculator for this chapter, trust me. All right, 4 to the -2. 4 to the -2, it's not -8, or it's not -16. It's 1 over 4 to the power of +2. See how it's think of it like this. 4 to the -2 over 1, well, it moves it to the denominator. It moves it down. All right, so 4 squared is 16. Okay, 4 to the -2 is 1 over 16. All right, you have this negative. As long as that negative is inside the exponent, okay, here's what you have here. This is an interesting one. You got 1 over 3 to the -5. So that means the base, okay, notice how the -5 became +5, 1 over 3 to the 5. Well, now we have to figure out what -3 to the 5 is. Now watch what happens here, and don't get confused. Well, try not to. -3 times -3 times -3 if I do that 5 times, there's 1, 2, 3, 4, 5. And I put that in my calculator. So if I have 5 negatives multiplied, my answer is going to be negative there. But it's not the exponent that made it negative, it's the base, because the base is negative. So that is negative 243. So the answer to that one is 1 over negative 243. Okay, I'm going to stop this video and make another one as we work through some problems here, as it gets it's not complicated, but it's really easy to mess up if you're not careful. So peace out. We'll be right back.